Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3.2 lesson on multiplying and dividing rational expressions. In this one, we will be multiplying and dividing rational expressions, as you might expect. For the real-life application, we're going to figure out how to convert paint area to time worked at a job, a little unit conversion. For the warm-up on this one, since we're going to be multiplying and dividing rational expressions, why don't we start by reviewing how to do that with just normal constants. Pause the video and see if you can do this one still. Alright, so now recall that when you're dividing fractions, you have to multiply the first fraction by the reciprocal, the flip, of the second fraction. In fact, there's a way of remembering this that you might have learned called same change flip. So we keep the first fraction the same, so 2/3. We change division to multiplication, and then we flip the second fraction, so 4/5 becomes 5/4. Now we still have to figure out how to multiply these. And you might also notice here, in particular, that the 2 and the 4, if those were in the same fraction, we would be able to reduce them. So there's two ways you can proceed at this point. Here's the long way. So the long way is to just multiply straight across. So we can make one big fraction with 2 times 5 in the numerator and 3 times 4 in the denominator. And at this point, if you wanted to, we can change the order of multiplication on either side. So I can write 5 times 2 in the numerator. And since I'm allowed to put these together by multiplying, I can actually split them up and unmultiply them into two different fractions. So I could call this 5/3 times 2/4 if I wanted. And at this point, we know that 2/4 can be reduced to 1/2. And then multiplying straight across again, we have 5 times 1 is 5. 3 times 2 is 6, so 5/6. So that's kind of the long way to do this. Now, a much shorter way of doing this, since we are going to put the 2 and the 4 in one big fraction anyway, because we're multiplying, we are allowed to actually, when multiplying fractions, cross-cancel factors that are in different fractions. So this only works with multiplication because, again, they're going to end up in the same fraction anyway, but you can kind of do this in advance. So the 2 and the 4, I'll just cross them off right away, and this reduces to a 1 up here, which we don't have to write, and a 2 down here. And now we have an invisible 1 times 5 is 5, and then 3 times 2 gives us the 6 in the denominator. So cross-canceling definitely can save us some time. Now that we've reviewed multiplying and possibly reviewed or introduced cross-canceling for fractions, let's tackle a rational expression here. So just like normal constants, you can multiply straight across. But the question is, should we multiply first and then simplify when there's only one fraction, or should we try factoring and canceling and then multiply what's left over? In practice, it's actually a lot easier to factor and cancel before multiplying. So that's what we're going to do. So actually take a moment, pause the video, and factor out whatever you can, and then cancel what you think you should, and we'll bring it back in a sec. Alright, so just rewriting the stuff I don't need to factor. The 20 and the 25 obviously are good to go. The 3x minus 24, we can take out a 3. That leaves us with x minus 8. And then for the x squared minus 8x, we have a common factor of x that we can take out of that, leaving us with x minus 8. Okay, so what can we cancel here? The x minus 8s, they're in different fractions, but we're multiplying, so we can cross-cancel those. And also the 20 and the 25 can reduce together. So if I divide each of those by 5, we've got a 4 up here, and down here this 25 is now a 5. And at this point, we're just going to multiply straight across whatever's left. So we have a 3 times a 4 in the numerator, giving us 12. And in the denominator, we have a 5 and an x left over. That multiplies to 5x. And just double check quickly to make sure you can't simplify this any further, but this is as reduced as it's going to get. At this point, we're going to take a bit of a detour for a real-life application of fractions. Not necessarily factoring and crossing off things with x's, but kind of close, so it's worth looking at. Let's say you want to paint your house, which has 3,150 square feet of surface area, and a gallon of paint. Here's your paint. It's a lovely purple, covers 350 square feet, and costs $20. So that's all for a gallon. And let's say that you also have a job and you're earning $8 an hour at this job. We want to know how many hours you're going to have to work to afford enough paint to do your whole house. So essentially our situation is we're starting with units of square feet of house area, and we want to convert that to hours of your life. So whenever you're doing unit conversion, fractions can be very helpful. We're going to use something called a conversion factor, which is essentially you're going to multiply by a fraction that's in a special form. The denominator in the fraction are the units that you're trying to get rid of, and the numerator in these fractions are going to be the units you want to convert to. And we can't do this all in one shot, so we're going to need a string of these fractions to make this work. So let's say we're starting with our 3,150 square feet, and I want to get rid of square feet. So I can do that with this 350 square feet over here. Now, what is 350 square feet equivalent to? Well, we said that there was a gallon of paint that was equivalent to that. So I've got my new units, gallons, and my old units, square feet. Now, the beauty of this is with our cross-canceling trick we saw earlier, those square feet cancel out. And now whatever you get from this mathematically is going to be in units of gallons, which is good, but it's not what we want. We want hours. So we're going to keep going. Now, one other kind of tricky thing here is we're allowed to multiply by this fraction without changing the original value, because even though 1 and 350 are not the same number, they're different units, and taking all this together, this is equivalent. 1 gallon and 350 square feet, in some sense, have the same value. So we're not really changing the value of what we started with. Okay, so now we're going to convert from gallons to something else. So we have 1 gallon, and what is that equivalent to that could help us out? Well, the only other thing we know about a gallon is that it costs $20. So we'll put $20 up here. Now the gallons can cancel out, and we've got units of dollars. But we don't want to know how many dollars it takes. We want to know how long you have to work. So we need time units. Well, here we have this other piece of information. You get $8 an hour, so $8 is equivalent to 1 hour. Now the dollars cancel. And we just multiply the numerator and denominator, and we'll see what we end up with. So multiplying the numerator, let me do this on the calculator, 3150 times 20, and that's going to come out to 63,000. And notice that we also have this hours that hasn't been crossed out. So we have to write 63,000 hours. And now down here, 350 times 8, let's see what that comes out to. 350 times 8 gives me 2,800. And there's no units left in the denominator, so that's just a straight up 2,800. And now 63,000 divided by 2,800. Let's do that. Divided by 2,800 comes out to 22.5. And we have hours left over, so that's 28 or 22.5 hours you'll have to work to be able to paint your house. Pretty neat. So we're going to do a couple more examples dealing with just the more algebraic end of this stuff. So we have this division problem here. Pause the video and see if you can figure out at least how to start this problem, and then just get as far as you can. All right, so we remember we have to use same change flip with division of fractions. So we keep the first fraction the same, we change this to multiplication, and we flip the second fraction to x squared over 12. And at this point, we just do whatever we would normally do to multiply, which often involves canceling and reducing first. So I see we have a 4 and a 12. Those can reduce. That gives me a 1 up here that I don't have to write, and a 3 down here. We also have an x to the 5th and an x squared. Those can cancel together, and that leaves me using my, my exponent rule, subtracting. We've got x to the 3rd downstairs. And what's left over? Well, in the numerator, we've crossed off everything. We still have a 1 up there, though. And downstairs, we have an x cubed times 3, so 3x cubed. We're going to do one more problem, and this will be about as crazy as it gets. Pause the video and go for it. All right, so very first thing we'll do, since we have division, we change that to multiplication. Same change flip. Keep the first fraction the same. Make this multiplication and flip that second fraction so that that 8x minus 24 is now in the denominator. And if you didn't believe me before about it being easier to factor and cancel before multiplying, well, hopefully this one convinces you, because if you were to multiply all this stuff together right off the bat, you'd get x to the fourth and a whole bunch of other craziness that you would then have to turn around and factor. So let's do the factoring and canceling right away. In the upper left, we can take out an x. That leaves us with an x plus 11. And then lower left, let's do that next. We need factors of 11 that add up to 12. Well, all we have is 1 and 11, and that works if you add those together. So we have x plus 1 and x plus 11. Upper right, we need factors of 6 that add up to negative 5. 1 and 6 won't do it, but 2 and 3 will if they're both negative. So x minus 2, x minus 3. And then down here we can take out an 8, leaving me with an x minus 3. All right, here's the fun part where we get to cross stuff off. These x plus 11s can cancel, and we didn't even need to cross cancel. I mean, these are in the same fraction. And over here, these x minus 3s can also go away. So what are we left with? In the numerator, we have x times x minus 2. And in the denominator, we still have an 8 and also this x plus 1. And that's as simplified as it's going to get. So that's it for this one. I'm pretty sure if multiplication were a sport, you guys would be the champs in your division. Until next time, Mr. Sutton signing off.